Welcome back, Math 30-2. Today we're going to look at analyzing exponential functions. We're going to look at a formula and seeing how it graphs. So to start off and to help us think about it, I have a little opening activity here. So in the show, The Walking Dead, each zombie bites and converts a person every day. Okay? If the zombie outbreak started with one infected person on October 1st, will the number of zombies overtake the population of Atlanta, 4.5 million, by October 20th? How long will it take the population of the United States is infected? So I want you to think about that. So let's take a look at this now if we were to graph this and the growth of the people infected. So every day what happens? So the first day there's one person, right? Starts with one. Day 2, how many people are going to be infected? 2 people. Day 3, how many people are going to be infected? Well, each of those bites on, so it's 4 people. So think of how that's going to go. It's going to make, what kind of graph do you think it's going to be? Is it going to be straight? Straight would be 1, then 2, then 3, then 4, but it's not. It goes 1, and then 2, and then 4, and then 8, and then 16. It's growing very fast. Okay, that's what's called an exponential growth. Okay, so here we go. Mr. Fody has a secret about the b value in an equation, all right? Can you figure it out? So we're just here going to look at the b value of an equation and see if you can figure out what my secret is. So let's go back to, I have a little thing here for us to look at. So here's my program. And I want to graph each of these and figure out what the b value is. So in each of these, the b value has changed. So first, let's take a look at this g of x. G of x says 1 over 2 power of x. So I plug that in, and it looks like that. First one is 2 to the power of x. Look how it increases. It started like with our equation is 0, right? And then it increases, right? So it's 0, it's 1. Then it increases. Here at 0, it is still 1. But this one decreases. Let's see what happens if I change it even more. Let's try this one. When I say it's 8 to the power of x. So that's still, my b is changed to 8. This first one, b was 1. First one here, b is 2. Here, b is 1/2. Here, b is 8. How is 8 different from 2? What do the graphs look like? Let's look at the next one. I have 1 over 8. Let's take a look at that one. This is 1 over 8. What's unique about 1 over 8? 1 over 8 and 1 over 2. What happens with those graphs? When b is 1 over 8 or b is 1 over 2? What's happening? Remember, the b value is the one that is being affected by the x. It's how many times it's multiplied together. Let's take a look at the next one. I have 16 here. That's interesting. 16. X is 16. Look at that. How does it shift from 8 to 16? The yellow and the green. What happens? And then even from 2. Okay, let's take a look at one more. My next one is 1 over 16. Where do you think this one will go, the 1 over 16? That's what 1 over 16 looks like. Now we have 3. Let's take a look at 3. Now 1 over 3. Here's my next one. It's going to be a little bit different. I'm looking at 4 over 3. This one here is when b is 4 over 3. Still a fraction. Look at my other fractions here. Here's one fraction. Here's another fraction. And then here's the next fraction. Now let's try this fraction here. 4 over 3. Well, that's interesting. It's increasing. But what is unique about 4 over 3 that the others don't have? Let's look at this 4 over 3 here. What's unique about this 4 over 3 that the others don't have? What's the difference between 1/2 and 4 over 3? Let's try 3 over 4. 3 over 4 is decreasing. Well, that's interesting. Now, based on this, can you figure out anything? So if b, maybe, what does the value of b tell you about the graph? How does b affect the graph? See if you could write it down. I have some guidelines here to help you out. So for each of these graphs, what is the domain and range? So in each graph here, what is my domain and range? Well, my domain is my x value. Can I have any possible x value? What about my range? My range is my y value. As far as I look at this, even if I zoom out, do I ever go below 0? Look at this. I keep on going forever. I don't go below 0. That's interesting. So what is my range? Let's take a look at the next one. The y-intercepts for each graph. So when we're looking at B, what are my y-intercepts? For all of these, I go very close. My y-intercept is always right there. It's always at 1. The x-intercepts for these. Are there any x-intercepts? Well, zoom out a bit here. Zoom out. Does it look like it ever hits? Let's take a look. Take a look over here. No, it doesn't ever really hit, does it? We get close, but it doesn't hit. So there are no x-intercepts. That's interesting. What about the horizontal asymptote for each one? Is there a horizontal or vertical asymptote? Take a look at this. Well, what can the lines never hit? Okay, so that's everything. So what are the horizontal asymptotes? And that could help you with A, or so with B. So there. Now we did a little explanation on what B does. So let's go back to this here, and we can fill out some parts of this. Okay, so here we go, exploring B. The x-intercepts for B, there are no x-intercepts. No matter what, as long as we have B, there are no x-intercepts, because the asymptote is there, so there are none. Okay? Y-intercepts for each is at 1. Okay? State the domain of each. The domain is x is an element of all real numbers. Okay? The range for each, y, must be greater than, just greater than, not equal to, it's just greater than 0. State the equation of a horizontal asymptote. Well, that is when y is equal to 0. Okay? So I just kind of solved those there for you based on that one. So now, here we go. The next part here is we're going to explore A, but I have a completely different way for us to explain A. It's the same way as what we did before. So, here we go. Now we're going to explore the A value. So my first one, right here, my A value is equal to 1. Okay? And that's our original graph. Now, I'm going to just zoom in a little bit here. Key thing. Okay? Now let's take a look at when it's equal to -1. Look at how my graph looks. So there, we're equal to -1, and there's my graph. Okay? Now let's take a look when A is equal to 2. What happens? Here's my example. A is equal to 2. A is not affected by the x is the exponent. Okay, it's outside. A is equal to 2. Look what happens. What changed? What about when A is equal to 0.5? What changes? There's the purple one. A is equal to 0.5. This is A is equal to 0.5 or 1/2. What changed? Let's take a look when A is equal to 1/2. What changes? Or sorry, -1/2, which is -0.5. What changed? Take a look at this one. What about when A is equal to -3? What changes? Okay. What about when A is equal to 5? What changes? So now, can you find any rules about A? What does the A influence? Could you guess if I said -5? Okay. So what does A influence? Pause. See if you could write this in here and figure out what A influences. What does B influence? What does A? So remember, A is the one that's not being affected by the x. So in these ones, A is 2. Here, A is 1. Here, 5, 0.5. B is the one being affected by the x. 3, 3, 3, 3, right? The x-intercept for each of these was what? Okay? So, here we go. Now I'm going to just do this here. You should have been able to figure that out and solve those above. So it says, without the aid of a graphing calculator, explain why none of the graphs below could be represented by this here. Okay, well, why not? So this one right here, I look at it, 5. Okay, so my y-intercept must be 5. No, y-intercept should be 5. Let's take a look at the second one, this one right here. Well, y-intercept's 5, but it's decreasing. So 4 is greater than 1, right? Therefore, my b is greater than 1, and it should be increasing. So every time b is greater than 1, it is increasing. My graph goes up. Every time it is less than 1, but it has to be greater than 0, it's going to go down, okay? The closer it is to 1, because it's 1 to the power of x, if b is 1, it's a straight line, because it's 1 to the power of 1,000 is 1, it's a straight line, okay? Let's take a look at number 3 here. Why can't this one be? If I look at this, my horizontal asymptote should be equal to 0, right? So my horizontal asymptote is the x-axis, and it crosses. The horizontal asymptote should always be where y is equal to 0, and it crosses the x-axis. So therefore, that graph doesn't work, okay? So right here they explored a little bit more, okay? So where a is less than 0, we already did that. We know what happens when a is less than 0 from looking at the other one. Now, we're going to go on here, and I'm just going to help you fill out this part here, so the following summaries. So it says, use the following information to determine the following. So the y-intercept is always my a value, okay? There are 0 x-intercepts. The x-axis is a asymptote. Okay? The domain is always x is an element of all real numbers. The range depends on if a is greater than 0. Well, if a is greater than 0, that means my y-intercept is on the positive. Therefore, y must be greater than 0. Now, if a is less than 0, that means my y-intercept is on the negative, so I already know y must be less than 0. It can't be above, okay? Now, the values determine whether the graph is increasing or decreasing. So if a is greater than 0 and b is greater than 1, well, that means from quadrant 2, just go over the quadrants, it's 1, 2, 3, 4. Okay, so from quadrant 2 to quadrant 1, so a is greater than 0 and b is greater than 0, we're going to increase. Okay, if a is greater than 0 and b is less than 1, well, that's like 0.5. What's going to happen? Our graph's going to go down like that. We are going to decrease. Okay, so it's going to be high and then down. Now, if a is less than 0 and b is greater than 1, that's going to be from quadrant 3 to 4. So a is less than 0 and b is greater than 1. Our graph is going to look like this. So it is going to decrease. Now if a, because that's technically decreasing, it's going down. Now if a is less than 0 and b is in between, my graph is going to look like that. So it's going to increase. Okay? Do we kind of get that? All right. So when b is greater than 1, the curve gets steeper as b, well, the curve gets steeper or closer to the y-axis as b increases. If b is in between 0 and 1, the curve gets steeper as b decreases. So as b gets closer to 0, the curve gets steeper. Okay? Do we get that? And here we go. So, and that's everything. Hopefully you understood this as you start the next assignment.